the set point, what we want as normal for our body. No matter how hot it gets outside. Okay? When it gets hot outside, our body does stuff so that our body temperature stays around 98 degrees. If it gets too cold outside, then our body does stuff to maintain that homeostasis for temperature. So homeostasis is a term, okay? Now, how we maintain homeostasis is through what we call feedback systems. Okay, feedback systems. Okay, feedback systems. So what a feedback system is we get data, and based on that data, we feed back a response so we maintain homeostasis. Okay, and the main one for our bodies is called a negative feedback system. There's positive and there are negative ones. Almost all of your body systems run on negative feedback. I will give you an example of positive feedback, but negative feedback. So again, I'm going to use temperature as an example. So if our body is set at 98 degrees, okay, that is our set point. Okay, if it gets hot outside and our body temperature goes up, then the body will kick in responses to correct the increase in body temperature back to the set point, okay? So if your body temperature starts to increase to like 101, then your body triggers, hey, you need to sweat, okay? So you need to sweat to cool your body off, and it's going to divert the blood flow to the extremities to carry heat away from your core, so that your body temperature will then return back to the set point. What if it's really cold outside? Let's say you want to go skiing, you know, if we get any snow at Flagstaff, then in a couple of months. And your temperature starts to drop, okay, to like 96 degrees, okay? Then your body's going to trigger responses to return that body temperature. You shiver, okay, because those are muscle movements creating friction, creating heat, and it diverts blood flow to the core, okay, to your core to keep this warm. So again, it's corrective, okay, so that's called negative feedback. Negative feedback systems are corrective. They correct the, whether it's an increase or a decrease, it triggers body responses to correct back to whatever the set point is. So at the set point, okay, if something goes above the set point, the body triggers responses to correct back to the set point, to go back down to the set point. If whatever the set point is drops, the body triggers corrective responses to increase it back to the set point. So that's, and most of our body's feedback systems to regulate temperature, blood sugar, pH, okay, the amount of oxygen in our bloodstream, all focus on what we call these negative feedback systems. An example of a positive feedback system, I'll give you two examples, okay? Childbirth is an example of positive feedback. Positive feedback causes a change to the system, so a permanent change. So for example, childbirth, okay? And it's only on the uterus. The uterus is a muscle, and so when the childbirth starts, the contractions start, okay? The contractions start. And then the body releases hormones to increase the contractions, and they keep contracting, and they keep going up and up and up and up and up and up until the baby's born, okay? That's an example of positive feedback, which resulted in a change in the system, okay? All right, another example of positive feedback, just to give you guys, if you think in terms of money. All right, let's say that let's say that you lose your job, and so you're not getting any pay, okay? So here's your bank account, okay? Your bank account's here. All of a sudden, you lose your source of income, you lose your job, okay? But you're still spending money, so what's happening? Okay? So you're getting in debt. So you start using credit cards that you can't pay off, so you're getting in debt. Okay? And you keep using those credit cards, so you keep getting in debt. And you keep spending more money. So you just keep getting deeper and 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 deeper in debt. That's an example. That is an example of positive feedback as well. Unless you get a job and you start making more money and you start paying the debt off, then we would change that back to negative feedback. Okay. All right. So very few things run on a positive feedback system in our bodies. Almost all of our systems that help us maintain our homeostasis run on negative feedback systems. Okay. And so when we talk about breathing, here, our bodies need to look at not the amount of oxygen, okay? So it's not the amount of oxygen in our bloodstream that our bodies are looking for, okay? What they're actually looking for is a change in pH by a change in the amount of carbon dioxide. So the more carbon dioxide gas that goes into the bloodstream, then your pH changes, okay? And so when your pH changes, that triggers the body to go ahead and want to correct that. So when it reads that you're getting an increase in the amount of CO2, then the body says, hey, wait a minute, that's too much CO2 resulting in a pH change, so now we need to correct that. So what does the body make you do? Okay, increases the heart rate, which increases the blood flow, which increases your breathing rate, okay, because it's interconnected there. Okay? There are also hormones that also help regulate your homeostasis. Hormones are like slow and steady responses, so long, drawn-out responses that you need. But there are some hormones that also help us maintain our homeostasis as well. Okay. So, do we have any questions? Okay. All right. And you guys can go into as much detail as you want on the cardiovascular system. You might need to review with them about blood flows to the heart that has high CO2, low oxygen, and then returns to the right side of the heart. And then that gets pumped to the lungs where the gas exchanges between, we dump off CO2 and we load on O2. Okay, you exhale out the CO2. Then that blood that's now rich in oxygen goes back to the left side of the heart, which then gets pumped out to the system, okay, to your tissues which need that oxygen. So let's say down to the tips of your toes and your fingers and your brain, okay, so we'll talk about that as just being extremities. And so that offloads all the oxygen to the cells that need that oxygen to function, and then the CO2 is a waste product of that process. That gets loaded back in, and then that now CO2 rich blood goes back to the heart, right side, to be pumped to the lungs, gas exchange, back to the heart, back out to the system. Okay? And they might ask you, well, how long do red blood cells, actually live? They live about 120 days, red blood cells. And so we do regenerate red blood cells. They do have a life cycle, and that they are produced in the bone marrow. Okay, in the bone marrow. So about, and again, red blood cells, about 120 days, is their life cycle. Okay? All right, so have fun with it. And again, the teaching notes are just a guide there. So if you want to go more in depth in a specific portion, then feel free to. Okay? All right. But it's a fun lab. The students usually really like this lab.